NASA has affirmed that its shuttle, Pioneer 1, right now the farthest human-made object in space, has once again started communicating important information to Earth. Albeit the subtleties of the object remain muddled, specialists can gauge its distance. Pioneer 1, sent off by NASA over a long time ago, has recently sent back a shocking message that has resonated throughout the scientific community. After traveling nearly 14 billion miles from Earth, Voyager 1 has made a discovery of such magnitude that it has altered the trajectory of its mission, prompting it to return toward Earth. This exceptional change in its path has sparked interest and speculation. Just minutes ago, Voyager 1 made a startling finding, causing it to shift its direction and head back to our planet. But what exactly has been discovered? Could it be evidence of extraterrestrial life, an extraordinary phenomenon, or something even more profound? In this gripping account, we delve into these thrilling findings as Voyager 1's discovery has prompted it to suddenly redirect toward Earth. According to records from the twin tests of the Voyager program, certain celestial events had to align for these two remarkable spacecraft to leave Earth. About a long time ago, the four largest planets in our solar system began aligning in a way unseen since Thomas Jefferson's presidency during the 1800s. This extraordinary planetary arrangement remained mostly unnoticed until Gary Flandreau, a doctoral candidate at the California Institute of Technology, recognized its significance in 1965, during the early days of space exploration. While working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was tasked with determining the most efficient route for sending a probe to Jupiter or farther destinations like Saturn, Uranus, or Neptune. Using only a simple pencil, he carefully charted the orbital paths of the major planets and made a remarkable discovery. By the late 1970s and early 1980s, all four planets were set to align so that a single spacecraft could visit them all, using gravity assists from each planet to propel itself toward the next. This rare alignment would significantly reduce travel time, shortening the journey from Earth to Neptune from 30 years to just 12 years. However, this planetary configuration only occurs once every 175 years. Seizing the opportunity, NASA decided to launch spacecraft during the early 1970s to utilize this once-in-a-lifetime alignment, Voyager 1 and Voyager 2. These twin spacecraft embarked on an unprecedented mission to explore the outer planets of our solar system. Thanks to the alignment and the visionary calculations by Gary Flandreau, the launch of these spacecraft on September 5, 1977, marked a grand milestone in space exploration. From Cape Canaveral, Florida, Voyager 1 began its epic journey into the universe aboard a Titan III Centaur rocket. Just 15 days later, Voyager 2 was launched on August 20, 1977. These spacecraft's primary mission was to study the giant gas planets like Jupiter and Saturn, along with their moons. However, they far exceeded expectations, traveling beyond their initial goals and breaking numerous records in their pursuit of discovery. They ventured into regions never explored by human-made objects, even reaching what is known as interstellar space, a completely unfamiliar region in our galaxy. Today, Voyager 1 and Voyager 2 are more than 12 billion miles from Earth. Despite their vast distance, they continue to amaze scientists with their groundbreaking discoveries. Their latest finding has left the scientific community astonished. In the past, the twin spacecraft achieved a series of remarkable accomplishments, including studying the moons of Jupiter and Saturn. These moons, once thought to be dull and cratered like Earth's moon, turned out to be dynamic, fascinating worlds. Voyager 1 made history by becoming the first of the two spacecraft to pass Uranus in 1986. Just 3 years later, it flew by Neptune, achieving something no other spacecraft had accomplished. As these probes continued their complex journey, NASA implemented various strategies to ensure their continued operation. They deactivated unnecessary parts like additional heaters and components to conserve energy. The goal was to keep them functional until at least 2025. For the dedicated scientists and engineers who had been involved from the start, this achievement was a combination of hard work and emotion. At the beginning of their journey, the Voyager spacecraft astonished scientists with their first close-up images of Jupiter and Saturn's moons. These moons, which astronomers once believed were dull and heavily cratered like our moon, turned out to be vibrant and dynamic worlds. Voyager 1 reached Jupiter in March 1979, just 546 days after its launch, while Voyager 2 followed closely behind, reaching Jupiter in July 1979. The detailed images and data they sent back revolutionized humanity's understanding of the outer solar system. Both probes revealed Jupiter's Great Red Spot in extraordinary detail, along with its intricate cloud layers and turbulent atmosphere. They also discovered active volcanism on Io, one of Jupiter's moons, making it the first celestial body beyond Earth observed to have volcanic activity. Similarly, Europa's icy surface hinted at a subsurface ocean, sparking debates about the potential for life. When Voyager 1 reached Saturn in November 1980, it unveiled the complexity of its iconic rings, revealing countless fine details such as ringlets and mysterious radial features called spokes. It also observed Titan, Saturn's largest moon, with its dense atmosphere of nitrogen and methane, offering clues about conditions that might resemble early Earth. Voyager 2, after its encounters with Jupiter and Saturn, continued its odyssey to Uranus in 1986 and Neptune in 1989. At Uranus, it discovered 10 new moons, a faint ring system, and a magnetic field unlike any other observed before. At Neptune, it captured breathtaking images of the blue planet's dynamic atmosphere, including supersonic winds and the dark storm later dubbed the Great Dark Spot. It also provided the first close-up views of Triton, Neptune's largest moon, which showed active geysers spewing nitrogen gas. By the early 1990s, both spacecraft had completed their primary missions and began what NASA termed their interstellar mission. In 1998, Voyager 1 surpassed the distance traveled by Pioneer 10, becoming the farthest human-made object from Earth. In 2012, it became the first spacecraft to enter interstellar space, followed by Voyager 2 in 2018. This milestone marked humanity's first venture into the space between stars. The data collected from interstellar space continues to provide invaluable insights into the heliosphere, the bubble-like region of space influenced by the sun's solar wind, and its interaction with the surrounding interstellar medium. Despite the vast distances, both probes have continued transmitting faint but reliable signals to Earth. Their nuclear power sources, however, are gradually depleting, and NASA has had to power down non-essential systems to conserve energy. As of today, Voyager 1 and Voyager 2 remain symbols of human curiosity and ambition. They carry with them the golden records, phonograph records containing sounds and images selected to portray the diversity of life and culture on Earth. Designed as messages for any intelligent extraterrestrial life forms they might encounter, the golden records are a testament to humanity's desire to connect with the cosmos. With their latest discovery, one so significant that Voyager 1 has seemingly adjusted its trajectory back toward Earth, the mystery deepens. Scientists and engineers are racing to decipher the information being sent, eager to understand what has prompted this unprecedented course correction. Could it be an anomaly in the spacecraft's systems, or has it encountered something beyond our current understanding of the universe? Only time will reveal the answers, but one thing is certain. The Voyager spacecraft, even after nearly 5 decades, continue to inspire awe and remind us of humanity's enduring quest to explore the unknown. Followed a somewhat unique way and showed up at Jupiter in July of that very year, outfitted with cutting-edge cameras that could rotate slower than an hour hand on a clock, these space probes caught more than 33,000 detailed photos of Jupiter and its moons, revealing new and wonderful information. For example, the moon Europa was found to have a thick icy surface with cracks more than 60 meters deep. As Voyager 1 and 2 left Jupiter, they were slingshot to much greater velocities due to gravity assists, propelling them toward interstellar space. The two spacecraft then proceeded on their different ways, with Voyager 1 passing through Saturn's notable rings and flying by Titan, a moon covered in an orange fog. Voyager 2, on the other hand, dared to Uranus and Neptune. In 1986, Voyager 2 made a huge discovery at Uranus, identifying 10 new moons and confirming that the planet also had rings. However, its accomplishments were overshadowed by a tragic event just days after its closest approach to Uranus. The Space Shuttle Challenger unfortunately detonated during takeoff, killing all 7 crew members including Krista McAuliffe, a teacher who was supposed to be the first civilian in space. As Voyager 2 flew over Neptune's atmosphere, it encountered the highest recorded winds in our solar system, reaching speeds of up to 1,000 miles per hour. The largest moon of Neptune, Triton, revealed itself to be one of the coldest spots known, with surface temperatures plunging to -235 degrees Fahrenheit. Additionally, scientists found frozen volcanoes on Triton that launched nitrogen gas and particles as high as 5 miles into the moon's atmosphere. After these stunning observations of Neptune, both Voyager spacecraft were set to shut down their cameras, signaling the end of their official missions. However, Carl Sagan, an astronomer and member of the imaging team, stepped in to push for an extension of the mission. This decision was driven by the hope that the spacecraft could continue their journey into interstellar space. The mission was then renamed the Voyager Interstellar Mission, and both spacecraft ventured further into the unknown. In August 2012, Voyager 1 reached a remarkable achievement by crossing past the heliosphere, the region of charged particles created by the Sun. The next year, a study published in the journal Science highlighted Voyager 1's significant finding. The spacecraft's plasma wave instrument detected strong electron fluctuations between April 9 and May 2013. This event caused electrons near the spacecraft to vibrate, indicating it had entered a region of higher particle density than the heliosphere. Although it might seem astonishing that electron density is higher in interstellar space than near the Sun, scientists explained that the electron density at the edge of the heliosphere is much lower than on Earth. By analyzing this data, researchers pinpointed that Voyager 1 crossed into interstellar space on August 25, 2012. This accomplishment filled the team with immense, unparalleled joy. Mission Chief Susan Dodd expressed her excitement, stating that the team was thrilled to see Voyager 1 reach this incredible milestone. Ed Stone, a key figure in the Voyager missions, emphasized how this advancement contributed to our understanding of space. He explained that Voyager 1 had helped scientists gain insights into the nature of energy and radiation beyond the solar system. Voyager 2 also crossed into interstellar space in November 2018, venturing into the unknown region beyond the Sun's protective bubble. Now here's the most surprising information. After an incredible 46 years of space travel, NASA's Voyager 1, the farthest human-made object from Earth, is still sending valuable data, despite being over 14.7 billion miles away. The spacecraft continues to operate far beyond its expected lifespan. This ongoing achievement, far exceeding expectations, is a testament to the durability and resilience of the spacecraft. However, NASA has projected that by 2025 Voyager may no longer be able to generate enough power to continue sending data back to Earth. Recently, something unprecedented happened during routine communication with Voyager 1 via NASA's Deep Space Network. After over 40 years of continuous data transmission, the spacecraft unexpectedly stopped its journey and executed a 180 degrees turn. This startling shift in direction has raised many questions and concerns, as scientists continue to analyze the data sent by the spacecraft. What could be the cause of this strange anomaly? The truth will surface eventually. As researchers dive deeper into analyzing the data from Voyager 1, the mysterious 180 degrees turn has sparked a wave of theories and speculations. Some scientists suggest that the spacecraft's onboard instruments may have malfunctioned, causing it to make an unintended maneuver. Others propose that the spacecraft could be responding to the changing conditions of interstellar space, such as variations in cosmic radiation or the presence of unknown forces in this uncharted territory. One of the most intriguing possibilities is that Voyager 1 might have encountered an unknown energy source or gravitational anomaly that influenced its trajectory. Such discoveries could provide groundbreaking insights into the forces at play beyond our solar system. However, despite the challenges, the mission team remains optimistic about the spacecraft's continued operation, as they monitor its status and keep sending commands in an effort to regain full control. Even as these questions remain unanswered, Voyager 1's success has already contributed immensely to our understanding of space and the universe. The spacecraft's data has transformed our view of the outer reaches of the solar system and beyond, allowing scientists to study cosmic phenomena that were once purely theoretical. It has also inspired future space missions, including the ongoing search for habitable planets and the exploration of distant stars. As Voyager 1 drifts farther into the vast expanse of interstellar space, it represents the enduring spirit of human exploration and discovery. The spacecraft will continue to send back valuable information for as long as it can, offering glimpses into the mysteries of the cosmos. In many ways, it serves as a symbol of humanity's desire to understand the universe, to push the boundaries of knowledge, and to explore the unknown, no matter how far away it may seem. Even if the spacecraft eventually falls silent, its legacy will live on in the data it has already collected and the inspiration it has provided for generations to come. As we look to the future of space exploration, the Voyager missions will remain a cornerstone in our quest for knowledge, reminding us that the universe is vast, full of wonders, and always waiting to be explored.